Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Chang'e 6, a lunar quest for knowledge. China's lunar exploration program, aptly named Chang'e after the moon goddess in Chinese mythology, has been steadily gaining momentum over the past 2 decades. With the upcoming Chang'e 6 mission, China takes a giant leap forward in its lunar ambitions. Scheduled for launch sometime in May 2024, this robotic mission aims to achieve a historic feat, collecting pristine lunar samples from the far side of the moon, a region shrouded in mystery and largely untouched by human exploration. Ever since the first robotic missions captured glimpses of the far side's unique landscape in the late 1950s and 60s, scientists worldwide have been eager to unravel its geological secrets. The far side, perpetually facing away from Earth due to the moon's synchronous rotation, presents a stark contrast to the familiar near side we see from our planet. Understanding how the far side's composition and history differ from the near side could shed light on the moon's formation, evolution, and its role in our solar system. Analyzing lunar samples from this region holds immense scientific potential, potentially rewriting our understanding of our closest celestial neighbor. A technological marvel, the Chang'e 6 spacecraft. The Chang'e 6 mission represents a significant step forward not only in lunar exploration but also in China's technological prowess. The spacecraft itself is a marvel of engineering, meticulously designed for the complexities of a far-side landing and sample return. Comprised of 3 crucial modules, the Chang'e 6 operates in perfect synergy. Lander. Equipped with sophisticated landing gear and a robotic arm, the lander is tasked with the delicate feat of touching down on the lunar far side. Once firmly anchored, the robotic arm will be deployed to extract core samples from the lunar regolith. Ascent vehicle. After the successful collection of samples, the ascent vehicle takes center stage. It will ignite its powerful engine and lift off from the lunar surface, carrying the precious cargo, the core samples, into lunar orbit. Orbiter. The orbiter acts as a celestial courier. It will rendezvous with the ascent vehicle in lunar orbit, receive the sample container, and embark on the long journey back to Earth, ensuring the safe return of the lunar treasures. The intricate coordination between these modules and the advanced technologies they employ showcase China's growing capabilities in space exploration. The Chang'e 6 mission stands as a testament to the nation's unwavering commitment to pushing the boundaries of scientific discovery and exploration. Destination: the far side craters. The landing site for the Chang'e 6 mission isn't random. Scientists have meticulously chosen a specific region on the lunar far side, most likely within a large impact crater. These colossal craters, formed by ancient asteroid and comet impacts, hold the key to unlocking the Moon's early history. The far side, shielded from the constant bombardment of charged particles and solar wind emanating from the Sun due to its position relative to Earth, they have preserved a more pristine record of the Moon's formation and bombardment events. In contrast, the lunar near side has been constantly bombarded and eroded over billions of years, potentially altering its surface composition. By analyzing the composition of the lunar regolith collected from these far-side craters, scientists hope to uncover a wealth of information. The samples could reveal clues about the Moon's internal structure, the materials that make it up, and the types of objects that bombarded it early in its history. Comparing the composition of far-side samples with those collected from the near side could paint a clearer picture of the Moon's geological evolution and its place in the grand narrative of our solar system. A fiery descent and lunar touchdown. The launch of Chang'e 6 will be a spectacle in itself. A powerful Long March rocket will propel the spacecraft on its journey towards the Moon. After a series of orbital maneuvers and course corrections, the critical moment arrives: the descent to the lunar surface. The lander module will detach from the orbiter and begin its descent towards the pre-designated landing site within the far-side crater. As it enters the thin lunar atmosphere, friction will cause the exterior of the lander to heat up significantly, creating a fiery spectacle. The lander's heat shield, designed to withstand these extreme temperatures, will protect its delicate instruments and the precious sample collection equipment. The descent will be a tense, automated ballet. Onboard thrusters will fire strategically, slowing the lander's descent and maneuvering it for a precise touchdown. Sensors will constantly monitor the terrain below, providing real-time data to the Mission Control Center on Earth. The successful landing of the Chang'e 6 on the far side of the Moon will be a monumental achievement, marking a significant milestone in human exploration of our celestial neighbor. A robotic arm on the Moon, collecting lunar treasures. With the lander firmly anchored on the lunar surface, the mission enters a crucial phase: sample collection. The robotic arm, a marvel of engineering with remarkable precision and dexterity, will unfold and extend towards the designated sampling site. Using a variety of tools and techniques, the arm will carefully extract core samples from the lunar regolith. The specific method of sample collection will depend on the nature of the terrain and the desired depth of the core samples. Drills or core hammers could be used to penetrate the lunar surface, extracting cylindrical rock cores that hold layers of material from different depths. Alternatively, scoop-like devices might be employed to collect loose regolith from the surface. Each sample will be carefully sealed in a sterile container to prevent contamination and preserve its scientific integrity. The success of this sample collection phase is paramount. These lunar treasures, untouched for millennia, hold the potential to unlock a wealth of information about the Moon's composition, history, and its place in the solar system. A lunar rendezvous and a celestial return journey. Once the robotic arm has completed its task, meticulously collecting the lunar samples, the mission transitions to its next critical stage: sample transfer and ascent. The ascent vehicle, nestled within the lander, will be activated and prepared for liftoff. The collected samples will be carefully transferred from the lander's storage container to the ascent vehicle, ensuring their safe passage back into lunar orbit. The ascent vehicle's powerful engine will then ignite, propelling it upwards from the lunar surface. This powered ascent will be a dramatic moment, marking the first time a spacecraft has lifted off from the far side of the Moon. After successfully achieving lunar orbit, the ascent vehicle will rendezvous with the waiting orbiter. This delicate maneuver requires precise navigation and control. The ascent vehicle will carefully approach the orbiter and dock with a designated port. Once docked, the sample container will be transferred from the ascent vehicle to the orbiter, completing the sample retrieval phase of the mission. The orbiter, now carrying the precious cargo of lunar samples, will then embark on its long journey back to Earth, paving the way for a new era of scientific discovery. The long journey home. A celestial delivery. The Chang'e 6 orbiter, now a cosmic courier, embarks on its journey back to Earth. This return trip will take several days, with the orbiter carefully following a calculated trajectory that ensures a safe and efficient return. Throughout the journey, Mission Control will closely monitor the orbiter's health and the status of the lunar samples. During this time, scientists on Earth will be busy preparing for the arrival of the precious cargo. A dedicated team will be waiting at a designated landing site, equipped with state-of-the-art facilities to receive and analyze the lunar samples. These facilities will be meticulously designed to prevent contamination and ensure the samples remain in their pristine state, preserving the valuable scientific data they hold. A touchdown on Earth, unveiling lunar secrets. After a suspenseful wait, the Chang'e 6 orbiter re-enters Earth's atmosphere. The heat shield will once again play a crucial role, protecting the orbiter and its precious cargo from the intense heat generated by atmospheric friction. Following a controlled descent, the orbiter will deploy its landing gear and touch down safely at the designated landing site. The successful return of the Chang'e 6 orbiter and the lunar samples will be a moment of immense celebration for the Chinese space program and the global scientific community. The retrieved samples will be meticulously extracted from the orbiter and transported to the waiting analysis facilities. A scientific goldmine, unlocking lunar secrets. The arrival of the lunar samples marks the beginning of an exciting new chapter in lunar science. Teams of scientists from around the world will have the opportunity to analyze these pristine materials, using a wide array of advanced techniques. These techniques could include geochemical analysis, Studying the chemical composition of the samples will reveal information about the types of rock and minerals present on the lunar far side. This information can provide clues about the Moon's formation and evolution. Isotope dating. By analyzing the ratios of different isotopes within the samples, scientists can determine the age of the lunar material. This information can help to create a timeline of events in the Moon's history. Microscopic analysis. Examining the samples under powerful microscopes can reveal details about the structure and texture of the lunar material. This can provide insights into the processes that shape the lunar surface. The analysis of the Chang'e 6 samples has the potential to revolutionize our understanding of the Moon. These samples could hold answers to questions about the Moon's formation, its internal composition, and its role in the early solar system. A stepping stone to the future. The Chang'e 6 mission represents a significant leap forward in human exploration of the Moon. The successful retrieval of samples from the far side paves the way for future missions that can further explore this enigmatic region. The scientific discoveries gleaned from these samples will not only enhance our understanding of the Moon but also provide valuable insights into the formation and evolution of other celestial bodies in our solar system. The Chang'e 6 mission also serves as a stepping stone for future lunar exploration endeavors. The technological advancements made in robotic spacecraft design, landing techniques, and sample retrieval methods will be crucial for future missions that aim to establish a permanent human presence on the Moon. The success of Chang'e 6 signifies humanity's unwavering quest to explore the universe and unlock its secrets, marking a new chapter in our lunar exploration journey.